Good morning. This is a presentation by FMS International aimed at understanding power loss in diesel combustion engines resulting from oil-based fluids. There are four main pathways through which contamination can enter the engine: through diesel fuel, through the air filtration system, through engine oil, and through the cooling system or glycol. Each of these will be explained in detail below. Diesel. If contaminated fuel enters the system with a high particle count, meaning an elevated ISO 4406 code, serious internal engine problems will occur. These issues begin with damage to the high-pressure pump, injectors, injector systems, and components of the combustion chamber, among many others. If this fuel also contains water and emulsions, the damage to the equipment becomes even more severe. Air filter. Engine problems will arise if contamination enters through the ambient air system. This typically occurs due to improper filter selection, poor filter quality, inadequate maintenance, or incorrect air filter replacement intervals. Lubricating oil. New lubricating oil does not always arrive in optimal condition or with a correct ISO 4406 cleanliness level. Proper oil maintenance and filtration are essential to prevent internal engine damage caused by the ingress of solid particles. Coolant. If a failure occurs in the cooling system, contaminants may enter the engine through glycol or coolant, causing significant damage to engine components and parts. Let us now analyze the four stages of power loss: incorrect dosage, loss of compression, contaminated lubricant, and premature saturation of the DPF, diesel particulate filter. We will examine each one, starting with incorrect dosage. Injection systems require diesel ISO 1187 to dose fuel optimally. Poor injector metering caused by particle contamination directly results in power loss and leads to increased fuel consumption of up to 5%. The second factor is compression loss. The presence of particles in the combustion chamber causes significant premature wear of the cylinders, resulting in compression loss. This leads to power loss and increased fuel consumption throughout the engine service life, reaching up to 7%. The third factor is lubricant contamination by particles, which increases internal friction and operating temperature. This condition causes power loss and an additional 2 to 3% increase in fuel consumption. Finally, the fourth factor is premature saturation of the DPF, diesel particulate filter. Excessive combustion-generated particles cause a pressure drop inside the particulate filters. This high restriction to normal exhaust flow results in up to a 2% loss of power and increased fuel consumption. So, what are the necessary steps to achieve optimal contamination management and control in diesel engines and avoid the damages described? The FMS concept establishes the first step as defining the current ISO definition of diesel throughout the entire operation. Using certified ISO 4406 measurement equipment, we visit our customers' operations to determine the ISO condition at every stage where fuel is received, transferred, or dispensed. In other words, we identify contamination levels across the entire fuel custody chain. In most cases, we consistently observe an increase of 1, 2, or even 3 ISO codes from the moment the diesel is delivered by the supplier to the final point of use. Based on the field data collected, the second step involves FMS designing the necessary engineering to achieve the highest level of fuel cleanliness within each operation. This is done through a technical contamination control diagram covering the entire custody chain. We define the appropriate locations and equipment to ensure that fuel dispatch times and operational procedures are not affected. The diagram may include filtration systems at fuel delivery points, breather filters or breakers on the main storage tanks, filtration on field fuel distribution tankers, and additional filtration systems installed at various locations according to specific operational requirements. In the third step of the FMS concept, we implement the required equipment for optimal contamination control at all critical points of fuel movement and custody: reception, transfer, point of use, and coalescence. The fourth step is ISO validation, carried out using certified equipment. The supplier is audited, and contamination control practices are confirmed in real time and online, allowing the user to validate the success of the FMS proposal and certify that the installed systems are achieving the intended cleanliness objectives. Once the customer has validated and certified that their field units are receiving premium, ultra-clean, and ultra-dry diesel, with an ISO code of 1187 or lower, they can measure their results and calculate the multiple technical, economic, and environmental benefits derived from the FMS premium experience. Thank you very much for your attention.